Okay, so problem 2 starts off with a definition that a worm is a non-negative integer in which the absolute difference between each pair of adjacent digits is 1. So 4, 3, 4, 5 is a worm, but 4, 3, 3, 4 and 4, 3, 5, 4 are both not worms. And also all non-negative integers below 10 are worms. And it says that you may use near in the problems below, which basically just compares two digits and tells us if they have an absolute difference equal to 1. Cool. So problem A is asking us to implement isWorm, which takes in a non-negative integer n and returns true if n is a worm and false otherwise. So just return true or false depending on whether or not n is a worm. Okay, so immediately I think like just given any arbitrary string n, for example, let's do 1, 2, 3, 4, 5. We know that this is going to be a worm because each kind of pairwise element is one distance apart. And we can kind of confirm this using an iterative approach where we compare each pair, right? Comparing these two, and then 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 if all of them are true, then we know it's going to be a worm. However, if you look in our skeleton code, we seem to have a kind of recursive structure laid out for us. So we're not going to do this iterative approach. Instead, we're going to try to solve this problem with recursion. Okay, so usually recursion looks like something like this, where we have our base case and then our recursive case. So what's our base case? What's like the simplest kind of input at n that we know the answer to? So if you remember in the problem, it says all non-negative integers below 10 are worms. So that's kind of our simplest case. So if n is less than 10, then we know that it's automatically a worm, so we should just return true. So what if n is not less than 10? How do we break this problem up so we can solve it with recursion? Well, if we go back to the original example of 1, 2, 3, 4, 5, what we can do is just compare, say, the last two digits. So compare these two, 4 and 5, and check if they're an absolute difference of 1 between each other. And then after we check these last two digits, which digits do we have left to check? Well, we need to check these two, and these two, and these two. So kind of the rest of n minus the last digit. So if you look at the skeleton code that they provided, they've essentially given us a template for doing exactly this. So we're calling near on n mod 10, which is 5, and we need to compare it to the second to last digit, which is 4. So how do we get to the second to last digit? Well, you do n florative 10, and then take that mod 10. Okay, so that essentially did this for us. It compared the last two digits of n, and now we need to recursively call isWorm to check all of the other digits excluding the last digit. So what this is essentially a call to isWorm on n mod 10. Okay, so that should be it. Just as a quick sanity check, let's make sure that what we've written is actually an option for all of these multiple choices. So our first blank, if n is less than 10, and yep, it looks like that's an option here, so I'm just going to fill that out. B is just fill in the blank, so I'll write return true. C, well, we wrote n florative 10 mod 10, which is an option right here. Oh, wait, that's not it. This one. Okay. And then for the last digit, we did n florative 10, which is right here. Perfect. So that was problem 2a.